So let's start with it. The title of the conference today is AI ML in Retail Intelligence, Real Use Cases and Challenges. This is a mix of different projects that we have been developing in our company, in NielsenIQ. So some of them have been presented some years ago, but as the people here at the university is renovating constantly, I suppose that for some of you will be new things, and I think that is interesting to share the findings in these projects. So, well, I'm going to start with the presentation. First of all, let me introduce myself. I'm Roberto Arroyo. I'm a PhD from this university. Not so far ago, I was here in this building, studying and doing research as some of you. I have been working in different research projects. What has derived in several scientific publications, patents, awards in my career, and it's really cool to be still on that side of the research here in the company. We have the opportunity to continue developing patents, scientific publications, and some other things that I will comment during the presentation. So probably some of you doing research are more familiarized with it. So I will show some things that we have done in the company during the last times. During my time here, doing the PhD, I did some research internships in Toshiba Research Europe, in the United Kingdom, and in the Australian Centre for Field Robotics in Australia. So I recommend to all of you at any stage of your career that take into account these opportunities and that you travel around the world, because it's one of the best things of the student time, of the researcher time, because you can meet amazing people, amazing professionals. You can work in projects that are different from what you are doing here. So totally recommended. And now, since 2018, I'm working for NielsenIQ in projects related to computer vision and natural language processing, which are applied to some of the business cases of the company. So about our team, the name is Architecture Innovation. This is something that has changed along the time. Probably if you have attended other years, the name was different, because in these big companies, things are moving fast. But this is the current name of the team. Our vision is to transform NielsenIQ by embedding cutting-edge artificial intelligence and machine learning solutions into our products. And our mission is to research, develop, and deliver maintainable and scalable, robust solutions. This is something that probably sometimes is forgotten in the research side, but it's super important also for the development of real applications, maintainability, scalability, and robustness. And we believe on that. And in improving the efficiency of our production processes. Now you are in the academia world, but if at some point you go into let's say the world of the companies, all the things that are developed in research must be previously studied, and some studies must be done before to guarantee that are useful for the business. So this is something that we also take into account always. Well, about some KPIs and milestones, we typically do applications for United States patents. In fact, we have one with this university, very recent, that is in the process of review. So it's something that is really cool to be here again, collaborating with the university. I think that this is super important. Companies must be here with you, because the collaborations can provide benefits to all of us, to companies and to the university. So I'm always totally encouraging to promote this collaboration when possible. So this is one case. We also present technical papers in conference and journals. Again, very recently we have published also with this university and with the Roberto research team led by Luismi. So it's really good to keep also this side of research in a company, because this is not so typical. There are some companies where this is forgotten and it's super important, not only develop solutions, but also contribute to the community and be there for doing research. We also have internal white papers for sharing our knowledge along the company, external presentations in various forums like this, apart from other meetups that we typically have done along Madrid or even in other cities or countries. This is something that we also consider important to make this diffusion of the things that we are doing. We have collaborated with top external institutions, with Microsoft, Google, the University of Oxford, the University of Alcalá, of course. We have developed millions of code lines to deliver real artificial intelligence and machine learning. This is something that sometimes is forgotten, but in the end is what makes this work. So it's something that we are also always involved. And we have developed different projects for helping several business cases, and that's what I'm going to show you during the presentation. Some of the projects related to artificial intelligence and machine learning that we have been developing during this time. Okay, so as a review of the content that we are going to see in this presentation, first of all, I'm going to do a very, very brief introduction to the basics of artificial intelligence and machine learning. Probably a great part of you know what is this, but in case someone in the audience is not super familiarized, just only some notions. Then in the second point, I will introduce one of the projects that we are doing in these areas of research in NielsenIQ. And then I will introduce some of the projects that we have been doing. Okay, so let's start with this introduction to the basics of artificial intelligence and machine learning. Well, as you may know, this is a long path along the time. Artificial intelligence started 70 years ago, so it's not a baby. It's something that has been developed by a lot of hands and a lot of minds along the time. In the 80s, in the last century, machine learning started to change the initial things that were performed by, let's say, the basic artificial intelligence. And what changed was that instead of engineering of making intelligent machines and programs, we start to have the ability to learn without being explicitly programmed. So it was something that changed this world of artificial intelligence. Then I would say that there was some kind of crisis during the 90s and early and the first years of the 21st century. But the popularization of deep learning about 15 years ago, more or less, makes this field again in the most top conferences, in the most top companies. I think that because at this point, it was possible to start to work on systems that were able to solve the real problems that we are currently having, right? Apart from the technique, also the hardware has evolved on the time, and it has also possibility the popularization of this topic, because the resources that are employed are terrifying for the 80s or other eras of the artificial intelligence. I remember when I started my degree 15 years ago, more or less, probably my laptop was worse than this smartphone. So this is what probably has changed the game at some points, apart from the technology, obviously, the algorithms that have been developed during the last years. Now, probably these techniques are more important than ever because of the popularization of unstructured data. 20 years ago, my part of data was very simple. It was stored in simple database. It was easier to process, I would say. This structured data can be displayed in rows, columns, and relational database, so it's more simple. It's some kind of simple things such as numbers, dates, and strings. And currently, it's estimated that the 20% of the company's data is composed of it. But during the last, I would say, 10, 15 years, the extension of unstructured data, such as images, video, audio, anything that you can imagine about multimedia, has done that we have a necessity of having new algorithms able to process this kind of information. So now, more or less, the companies are having like 80% of data related to this unstructured data, images, video, audio, documents, etc. And it changed everything because the idea with structured data for doing some kind of automation was easier, but with this, there are more complexity. And if some of you are working in areas such as computer vision, natural language processing, you know that this is not an easy thing, right? So this is also a graph to see this evolution, and it's very, very recent. Not so long time ago, we have a similar amount of unstructured and structured data, but as you can see in the last years, there is an exponential growth. So this is probably because of the popularization of platforms such as YouTube, Instagram, I don't know. This kind of web-based system that stores a lot of information of unstructured data that must be controlled at any manner. So this is just a little introduction to put in context this kind of things. Now I'm going to show you some of the projects that we are developing in artificial intelligence and machine learning in NielsenIQ. We have much more because the company is super long. There is a lot of people working here. Now I think that we are like 40,000 people around the world. We are working in more than 100 countries. So imagine that there are a lot of projects and business cases that require artificial intelligence and machine learning because the way of doing things in the companies related to market studies or consumption that are the main topics of NielsenIQ were using traditional systems before. You have to obtain information for research studies, I don't know, related to consumers. Some years ago, an auditor went to the store and manually annotate the information that is required. But obviously, it has changed along the time. And now we need systems that facilitate the process and that provide more efficiency. In this sense, artificial intelligence and machine learning has helped a lot to achieve this. Some years ago, it was more difficult because, as I said, the systems, the hardware, and even the software were not so powerful as now, but I think that now it's easy to have some intelligent systems in companies that make a real benefit for them. Regarding the projects that I want to show you today, I'm going to show you 5 from a long list that we have in the company. The first one is e-collection, that is focused on product prices and promotion recognition on self-image. This is the the typical thing that some auditor goes to a store, and in the past they manually annotate how many products you have in a store and so on. But now they just only have to go through the store, take a photo, and the intelligence is able to make this count by itself. Then I'm going to show you also a use case related to item coding, that is the automatic extraction of features from product images for reference data. This is also a use case that is typical not only in NielsenIQ, but in a lot of businesses around the world, that is extract information from products. Like I will show you examples later, but for example, if you have a product packaging, you have a lot of information that companies are archiving in the past by manually annotating everything, which is a pain. And today is the same. You can take a photo, and the system is able to read the information in the package and extract the information of interest. In a similar line, we also have document decoding. This is a project that we have for extracting information from retailers' purchases, like invoices, receipts. And this is also of interest for obtaining information about retailers, brands, and so on. In these documents, you typically have information about purchases, products, prices, and so on that is of interest for different business here in the company. In the fourth case, we have Releaseless. It's a project used to categorize and itemize the products and promotions contained in a leaflet. The typical digital leaflets that you have for promotions on the internet are processed to extract the information. This is also used for digitized physical leaflets. And we have also things for e-commerce related with this use case. And the last one, and probably one of the most interesting from the research side point of view, is BQA for store observation. It was a project that was developed in collaboration with this university, with the research group. So it is very interesting, as I said, that we can collaborate with institutions and research group with so long experience in this kind of techniques, and be possible to do this kind of projects. In this case, what we were doing was predicting the category and was like answering questions that can be made by a human in a natural language. So the system is able to recover this information and give an answer to these questions. This is commonly used in applications for various things, like, for example, frequently asked question systems, where you have to have like a technical service that normally requires a call to explain a problem and so on. So in the typical cases, you can use this for automatically answer the questions of a client. Or in the case that we have presented here, in store observation, we have auditors that are in charge of going to the field and take the photo to the shelves and having the data acquisition to count the products that we have in a shelf, like I explained for your correction. And in this case, these auditors typically have doubts because of cultural gap. For example, if you are working from India and you have products from Spain, probably some of the products are not understood by the people in charge, and they sometimes don't know if they have to code that or code there. So it helps to avoid a constant iteration with the technical assistance, because some of the questions are very easy to solve with an artificial intelligence. So you can avoid the interaction with a human operator that is more has a higher time consumption. Okay, so I'm going to explain more detailed its use case. The first one is the collection. As I explained, this is for automatic localization and classification of products using deep learning and computer vision techniques. This is based on convolutional neural networks that is something that in the last years revolutionized the state of the art in computer vision. Now we have other alternatives like transformers that are pushing hard here in this field, apart from in natural language processing. But in this version, we are using convolutional neural networks. Here you have a typical example. We have an image of the shelf in the store. First of all, we apply a product localization algorithm to know where are the position of each product. And then we have a product classification where we take the product located and we pass through the network, and it is able to say, okay, this product is a Coke, or this product is a juice, or any other kind of thing. Apart from that, we also have algorithms for promos detection and matching. You know, in a store, you typically find these 50% promotions or 2+3 or things like this. And we are able to detect it. And this information is very important for the business to understand how to locate the products that are in promotion and this kind of thing. This is a field that is far from me, but last year I read a paper from this university. I don't know who was the author that was researching about that, about how organize stores to sell things. And this is something that is super curious, because when you go to the market, you don't think on how you are doing things, no? You need milk, you go for the milk and so on, but there are studies to allocate properly all the products in a store to make it more attractive to the public, to make it more visible and so on. So this is used for these kind of things. And we also have price recognition and matching to obtain the prices of the products. And this can be also used to see which products can be used for promotions and other things. Okay. So going forward into more things related to the project, this is a global solution. We have generated models for more than 20 countries, and this is growing constantly. We are having more and more projects that are requiring this technology. We have models with more than 50,000 classes. And I want to highlight this because in the last conference that I have been 2 years ago, it was the CDPR, 2 or 3 years, I don't remember. And it was in United States. We were talking with other colleagues that were doing similar things. And the major part of system only allow hundreds or as much 1,000 classes for this problem. So the good thing of our models is that are able to classify a very big amount of products because of the technology, and also because of the data of NielsenIQ. We have very powerful data acquisition. And in the end, this is the key for making it work for any deep learning or machine learning algorithm. Related to this, in our training set, we have millions of training images. This is updated every week because this is a system that is constantly working. In fact, this is a cool thing that, for example, in academia, probably is not so important, but here is very important. That is that we need to keep update the system constantly, because you can have new products, you can have new things to check. So every week we have to retrain the models, take new samples of the new products, and retrain the models to make it work and to keep the KPIs, the performance of the system. Initially, we have to do this by ourselves, but now we have also automated the training system. And this is super cool because you just only need to monitorize the performance and the KPIs, and you don't have to do anything else. There's only some maintenance, and this is the key of a real artificial intelligence project, because solutions are normally not, let's say, having a good performance forever. You need to retrain normally because you have new data, new things to recognize. And if you have to constantly train the models and do all the manual process, download the data, train your model, tune the parameters, you're not going to have benefits because you have to get involved a lot of people on that. So if you automate all of this, things are easier and also more efficient, and also they provide more benefits. Another interesting thing is that the data sets are unbalanced. What does it mean? That for some products we don't have much samples, and this is something that is risky for a machine learning or artificial intelligence model, because you can have a lack of information for some of the classes and have a tendency to recognize some others with more samples. So here there are solutions related to data augmentation to generate synthetic samples. So, well, this is something that can be solved with this kind of technique. I haven't mentioned, but about the amount of classes that we have problems like this, which are products that are visually really similar. This is what is called fine grain. And this is one of the cases more challenging for this kind of systems, to differentiate this kind of images with slight differences that even the human eye has difficulties to differentiate. So this is something that we also face not only in this project, but in a lot of them. Probably if you are working in computer vision or doing any kind of project or research here on that, you have suffered from this, and it's something super typical in a lot of problems. As I mentioned, we have new products every week, so we need a continuous learning for the system. And we have more or less to process 200,000 images every month. Probably this amount is even bigger now because it is constantly growing, but this is more or less the numbers that we had recently. If you want to know more about this project, we have some materials. I did a conference when we were initiating the project 4 years ago here at this university. Probably some of the things are not super updated, but to get the concept in detail, probably you can have a look. This video is in YouTube. And also we have a promotional video, and probably I can this just to keep an eye. So this is more or less the thing, right? We have a lot of stores that analyze, and you have to keep the information and so on to make the consumers happy, let's say, with the organization of everything, with the products that they are having. So this is what we are doing, going to the market. In this video, until now we are seeing just only some clients buying things, but I suppose that here we have some things more related to the artificial intelligence topic. These are a representation of the store that has been made with three-dimensional representations. This is something that I haven't worked, but it's super cool also. And the products are obtained, as I have explained, with the collection. So this is like a very powerful system. As you can see, this is what the system has acquired. And this is super useful for market organization. I know that probably if you don't know about this work, this is something strange, so the application is difficult to see, but believe me that this can give markets millions of benefits, the organization of the products, the storage, and so on. Apart from that, we have some publications in some conference. This was in a CDPR workshop. We have some patents. You can keep an eye if you want to know more about this. Let's go with item coding. This is another interesting project that we are developing. The previous one was super focused on computer vision, but it also adds natural language processing. My education here in the PhD was more focused in computer vision, but during the last years, I have been also doing a lot of research in natural language processing because it's getting more and more connected with the computer vision world. In this case, in the last year, the popularization of transformers have joined even more these worlds. This is something that started in the natural language processing world, but now has been adapted for computer vision because the structuration of the information in images and text can be correlated at some cases and misused. So this also includes natural language processing. The idea is that we have product packaging, and in a traditional system, you have to take manually or with your keyboard all the information, and obviously this is not efficient. It's something that is very repetitive. It's a task that can be automated. So this is one of the ideas behind this, that is obtaining information with computer vision and natural language processing. As you can see here, from the package, there is some information of interest, the nutritional facts, where you have all the information about the characteristics of the product, like proteins, carbohydrates, and so on. In green, you have the ingredients. This is the region of the ingredients, or even some nutritional logos. This is what the system initially did, but there is also other information of interest that we are also taking, such as addresses, instructions, storage, pack size, brand, usage, safety warnings. There are a lot of information of interest in these packages. So the structure of the information is also performed using convolutional neural networks and also some natural language processing algorithms. Here again, we are not still using transformers, but we are also working on that. So probably in some time, we are also mastering these algorithms for this use case. Apart from this, another important thing in any system where you have tests involved or natural language processing are languages. If you have a system that has to work in a worldwide fashion, you need to have it available for some different languages. And this is something that is a problem because the language can be very different. Here in the samples, we have Dutch, French, or Spanish, that are languages that are saying the same alphabet, more or less similar rules in grammar. But if you switch to Chinese, to Arabic, to other kind of languages that are containing other alphabets or other grammatic rules, the thing is more complex. So this is something, multilingual is another topic that in natural language processing is now in all top conferences, and it's something that is very studied in the community. So this is an example of what the system is doing. In this case, we are showing the detection of the ingredients. In the green boxes, we have the regions where they are detected. OCR is used to obtain the words. Then they have to be joined and associated depending on the ingredient, because they can have more than one word, and this is also done using natural language processing algorithms. And then we have also the detection of nutritional facts that we present as a table. This also involves graph neural networks to do the stuff. It's a little bit more complex than the extraction of ingredients, but this is more or less what the system is doing. Again, if you want to know more about this, we have some resources that are available on the internet. This is a talk that I did some years ago. Also here, this is a promotional video from Brandban. That is the a company acquired by Nielsen some years ago that is specialized in this business. So if you want to have a look, you can check in this web address. And this is a post in Medium that we published some time ago also. Apart from this, we have publications in some CVPR workshops. We have also some patents. Well, there is a lot of things to have a look if you want to know more. The next one is document decoding. This is something that is probably one of the top topics in any company dedicated to develop artificial intelligence systems, because now there is a big interest on decoding documents with automated solutions for a lot of cases. Here I'm going to present one for a purchase document, but it is applicable to very different fields. So in this case, we have a document decoding system that is an approach for automatically decoding the purchase facts from images. And when I say purchase facts, this is the product codes, the product descriptions, the prices, the quantities of each product, the retailer, the manufacturer, well, all the information that you can imagine. In this case, I'm showing a system that is detecting for facts, but we have systems with much more cases and more complex. This system is deployed as part of the NielsenIQ document decoder service that is designed to support several types of documents, invoices, receipts, etc. And the idea is to take a photo with the smartphone, digitalize the information of the document, send to the cloud service that is in charge of decoding, and invoice decoding system is doing the stuff. It seems easy, but technically it's very complex because it involves a lot of algorithms related to computer vision. Again, optical character recognition is always a bottleneck for this. Normally you need very, very accurate character detection. But there are also involved other techniques in the state-of-the-art of natural language processing that are very important for making it work. In this case, for identifying the words of interest and classifying them in different categories, let's say, there is a research topic in the state-of-the-art that is entity tagging that is very related to transformers. I would say that transformers started very related to this. Well, the idea is to receive as input all the OCR words extracted from the image and categorize them into different classes. This is like a classification problem, but it has an additional complexity, that is that you have to relate all the words. So in the major part of cases, this kind of architectures are also composed of graph neural networks. So it's very complex. Here I'm showing very simple examples because I think that is more understandable and understandable, but believe me that the complexity of a natural language processing system can be very, 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 very complex. So, well, about this project, we were also doing a conference some years ago here with more materials. We have also patented some of the things that we have doing in this project. Well, as I said, it's something that is one of the top problems in the natural language processing. All this document decoding thing. In other projects, not in Nielsen, but some projects that I have seen in the community, it's also very typical to analyze historic documents. It seems that there are a lot of people involved in obtaining information from historical documents from some centuries ago. There is a research line very interesting also on that, because normally the test is handwritten and it's more difficult to understand by the system. So there is a lot of research on this. Well, here we have Releaseless. This is another project involving computer vision and natural language processing. Here we have this leaflet that you are seeing there that contain valuable information such as product descriptions, product images, price and type of promotion, the area dedicated to each promotion, and all of this information needs to be extracted, because normally you have these leaflets, but you don't have the associated information at any part in a database or something like this. So it needs to be extracted directly from this kind of images, which can be a pain if you don't have automated systems. Understanding and extracting this information in e-commerce platform is a very valuable asset. Understand the assortment of retailers, analyze consumer patterns, or the impact of promotion. Well, these are things that for the business are super important. Well, from our side, we are researchers and we are focused on the algorithms and so on. But I would say that for working on research, you also have to understand the use cases, the business, and everything to understand the real necessities of a problem, right? Because in the end, research is on service of the people, of the companies in the case of the company's work, and it has been adapted to work on the specific problem. So this is something very important, and that in research is also a key topic to adapt the things to the use cases of real work. So in this work, we focus on the categorization of promotions and extraction of relevant information. Here again, we have a lot of computer vision algorithms, a lot of natural language processing things. This is like a simple representation, but the extraction of information in some cases is more difficult. I'm also showing beautiful images. Normally, these images are not so beautiful for document decoding, for e-leaflets, because the people that is in charge of taking the photos can use different mobile phones, different resolutions. Sometimes they take the image rotated with blurring, with a lot of things that makes everything much more difficult. The ideal thing would be have something like this where everything is perfectly visible, but this is not the normal thing. So this is something that can be a topic for another conference of 1 hour, all these things of data acquisition and how this data can be improved. But well, today is something more relaxed, and just only want to show you some of these use cases. About this, we have also extended material. As you can see, we are publishing almost the major part of things that we are doing. About this paper, we are very proud because we published 6 months after starting to work in natural language processing in one of the top conferences. I'm still, I don't know still how we did, but it's there online. The conference name is Colin, and it's one of the top conferences in natural language processing. We presented the work. Here you have the video of the conference that we did. We have also patented it. That's the thing. Here in the company, the things that are published must be previously patented to be protected. But when they are protected, we also like to do some dissemination of the things that we are doing. So this is about iLeaflets. And finally, the DQA for store observation was a project that started 2 years ago, more or less. I remember that we started during the pandemic times. We didn't see in person during all the project, I think. So it was more difficult for the interaction, but I think that the work that was done was fantastic. We were collaborating with Duismi and the Roberto research group, and the things that we did, I think that are very, very valuable for the company and even for the community, because this is a topic that is growing a lot during the last years, but it's very, very complex. So the solutions that we have in the state of the art are not still mature enough, and all the contributions are very important for the state of the art. And just to explain you what is this, DQA is a topic where you have an image, you have a natural language question about the image, And the task of the BQA system is to provide a natural language answer. This can be seen as something easy, as a concept, but technically it's super complex. Probably one of the complex problems that I have faced during my career. This is because natural language is an open world. Sometimes it's difficult to predict what is an answer to something. I don't know if some of you have at home something like Alexa, Google Home, but if you ask a question, probably the answer is not what you expected. So imagine that for these cases, it's similar. It's also a complex thing. And we are talking about systems developed by Google and Amazon that are top companies. So believe me when I say that this is very complex thing and that it requires a lot of efforts in the technical side. These are some examples. For example, here we have what is the main product on the store shelves. The first one, the answer is apples, and in the other case is books. We have also Boolean questions like, are there bananas? Here in this image we have some bananas here, so the answer is yes. Here we don't have, so the answer is no. We have also numerical things. How many pineapples are there? Here we have 3. Here we have 0 because we have apples. Well, this is more or less the idea and some basic cases. I would like to show you some demo about this. This is an application that was done by the Releaseless research group in collaboration with our company. In fact, I think that, well, in fact, no, it's still working because I connected some days ago to check and everything works perfectly. And this is a video of how it works. So let me go video. Here we have the system. It allows you to introduce a question. For example, here it was how many cells are in the image. We have 7. The system is predicting properly. Here we have other example where the question is, what is the category of this product? And the answer is whiskey. This is a bottle of whiskey. Also visually it's not very well seen, but is it. Here for the brand again is giving a good answer. Here we have another case. What is the name of the brand of this product? And the answer is Super Drug T3. That is correct. And well, we have some other examples. I don't know what is coming now, but the question is there any product from the brand name and Kona that is a cleaning product? No, sorry, it's a sauce product. And the answer is yes, because they are all sauces. Here we have another example that is like the opposite. Here we have the cleaning products, and the question is there any product from the brand Kona that is from sauces? And as we don't have any of them, the answer is no, because we don't have any kind of sauces here. They are like cleaning products or something like this. So well, the video is longer, but I think that the concept is more or less explained with it. One good point of this project is that it's also deriving a lot of research publications. Here we have one that we did in the WAF conference that I think that was held here in the University of Alcalá. We also have a newer publication in a journal in multimedia tools and applications. It's not here because I didn't update this slide, I think, but it's a research work derived from this that is published in a journal too. We have also a patent that is in process this year. We are working with the people from the legal team of Nielsen to make it happen. Okay, and that's all. Thank you very much for coming. And if you have any questions, I will be delighted of answering you. Thank you very much.